Hello. Okay, how's everybody doing tonight? Good. All right. As you came in, you might have seen this device. I'll talk about that real quick. This is an Internet of Things device. It's basically an LED screen with what's called a particle photon, which is a Wi-Fi device. It connects to Wi-Fi here. It sits on top of what's called a breadboard, and the wires connect from the breadboard to the LED device to the lithium battery. Okay, it's ran on Arduino LED screen with a photon particle, which these are made. This is a Wi-Fi device. They also make a cellular device as well, and what's called a mesh, like municipalities and regions to use for larger rollouts. But the whole concept of IoT is basically to, I'll put that here, to control or read anything connected to the internet. That's the basic definition for Internet of Things. And let me show you on the overhead a better definition than that I actually have on the website, rbciot.app, which is the website or the course that's registered for now for Summer 1. It just opened up, when was it? Sunday or Monday, the 26th. And it's starting to fill up. But I'd like for you guys to be a part of it if you can make it. It's 4 Saturdays. And the Saturdays are, the schedule says 7:30 to 1:30, but we're not doing 7:30 to 1:30. We're going to do May 18th, 25th, the 1st, and the 8th. So May 18th and 25th of May, the 1st and 8th of June, from 8 to noon. Check-in will start from 7:30 to 8, basically. You have time to come in and check in. So from 8 to noon, once you get done, each Saturday, you'll take home a project you've completed, like this. And so let's go over what Internet of Things is a little bit more in detail, nothing real over in depth, but just kind of an overview. How many has at your home right now? You can think of a device that would be considered an Internet of Things, which remember is anything connected and controlled via the internet to the world. So like a doorbell, thermostat, lights, your car, from being able to turn it on and off, to your television, setting notifications via maybe an Amazon device, a Google device, a Google Home device. So can anybody think of anything in your home right now that you currently use that you didn't think of was IoT? Yep, what was it? Roku, that would be considered an IoT device for sure. Definitely, it's connected to the internet. Smart TVs are IoT devices, yes. So these are things you already use already. You didn't maybe realize was an IoT device, and they are. Now the ones you're mentioning are used for entertainment, but they're still an IoT device. You're controlling it over the web, and most of these you're talking about, if you have the right app on your phone, you can even control it from here if you wanted to, and change a channel or whatever. Record a show, whatever you wanted to do, probably. And so it began actually, believe it or not, in the 70s with the very first ATM is an Internet of Things device. And we use those all the time, I'm guessing. You still use them. Big businesses are using them when it comes to Morgan Stanley says that by 2020, there'll be enough IoT devices in the world to have 7 devices per person at that time, at 2020. That's just 1 year from now. $60 trillion in investment in IoT in the next 15 years, according to GE. Big businesses are already ahead of the curve. And that's one of the reasons why we're offering it in May, summer one. It's been asked to be offered in the past. Now it's kind of a prime time because there's local businesses actually asking for skilled workers in the IoT area that know how to set up these devices. You don't have to technically be a programmer or be a technician. It's a unique skill set to be able to set up one of these devices and to be able to code it and for it to work. And so companies are asking for, and they'll be asking exponentially more of those type of skills. Also, we'll talk about the dark side of IoT when it comes to security, wearables market, watches, wearables as far as clothes, medical wearables as far as tracking your heart rate and breathing, things like that. You've heard of that maybe, or maybe something like the Fitbit or some type of fitness apparatus that you use. That's an IoT device. $53 billion in the home market currently in IoT, from lighting, the thermostats, to anything smart home connected. So lightning, thermostats, blinds, garage door, camera security, things like that. And then smart and automated driving. Already, any new car you buy today, in the last couple of years, has some type of IoT built into it, whether it be starting the vehicle, diagnostics of vehicle, telling you when your tire pressure is low, gas is low, needs a maintenance, whatever. So all of these things they're not just cool, which they are cool, they're actually helpful because they help you with saving energy at home and at work, helping your vehicles last longer because you can get maintenance on them when you need to versus waiting for it to break down like we've always done in the past, right? On the business side of things, but number one way IoT is used is in inventory. So if we could pretend that in this room we're a factory and this is all an assembly line and this table here is full of product with little bins, how do we know, or who is it now, if we just product in a bin and we're all workers here, who's going to order when parts get low? Or number one, who's going to determine when parts get low in this situation here? No electronics right now. There's bins with parts. Somebody's going to have to, right? Somebody in the building, somebody in the group is going to have to, we're getting down to 5 items here in the bin, we need to reorder. Well, guess what? That doesn't always happen. And so because of that, companies lose sales because things aren't ordered. So customers go to other places. So inventory control is one, because here's how IoT works with inventory control. In the bins, as you're taking items out, it can sense if there's 100 items in it. Each item you take out, it decrements the item count. So when it gets down to say 20, it automatically reorders another 80 or another 20 or 40 or whatever the case may be. So you're never behind in your parts or never behind in your pieces or your bits for your company, right? Secondly, with inventory control, theft is a big way inventory control is lost in companies. Well, with IoT, you can actually put devices at the door and devices at exit levels to track items as they leave. Have like let's say, I don't know, an RFID tag on all the parts or something, just like you do with the stores when you walk out, if you don't pay for something, the alarm goes off. That type of technology is IoT. So you have that in a workplace to stop that, basically. Yeah.
My daughter works at Amazon, and they use scanners to scan all the items that they pick off the shelves.
Oh, yeah.
And that keeps track of the inventory. But it also, I was surprised to learn that it times them as well.
Oh, yeah.
So like how often they're scanning things. If they're like idle for too long, then they get blocked for that.
Hey, Jill, you took way too long on the last 100 parts.
So it's
You're
like
supposed to go 10 seconds per part. You were taking 12 seconds per part.
Yep.
Whatever, right?
Yep.
Oh, yeah, there's a video I'll show you actually reminds me of that with tonight of the little Ultibots we're doing for the K through 12 kids. It's a line following robot. Well, Amazon uses those line following robots for all their shipping, all the warehouse stuff. So instead of folks like your daughter going to the shelf actually uses a robot to bring the shelf to them, and they're wherever they're standing at. And then when they're done filling the bin, it puts the shelf back to the spot in the warehouse where it needs to go. Again, that's IoT as well. So there's shelves moving around all the time in the shop, and people are just standing here. The shelf comes up, and they put the bin in. The shelf moves off, brings another shelf in. And so yeah, that's all IoT as well. So everything we're mentioning, as far as what the example here is really not a lot of money to implement IoT, by the way. Like each one of these projects we're doing for May is on average about 45, 50 bucks to create it yourself. Now, if you go buy it off the store shelf, like if you ever create your own Nest doorbell, which you can do for about 35 bucks, you buy a Nest on the shelf, I think the last I checked, they're like 120, 150 bucks. So, it's a large markup as well in the market. And so companies, when they create their own IoT, which they do a lot of times, will save money because they can do it in-house. They can customize the IoT, how it works with the scanners or with the robots or with the sensors. So all these things kind of play in to save companies money. Harley-Davidson is one of the big companies I can think of last year that implemented IoT in all their inventory. It saved like $60,000 the last quarter of 2018. And so that's a lot. That's somebody's salary, probably one person's salary in the shop. And so that's the business side of thing. On the home side of thing, we already talked about a little bit. And so basically IoT is something, whether or not you will go into the field as an IoT creator and programmer, we will all and are being touched right now with IoT, right? In all of our lives. And so I'm thinking the course will also be helpful if you want to just take it just for that. Just know more about it, know how to create it, and nothing else. You have 4 cool projects at the end of the 4 weeks that you can say you created and you can use in your home or at your work. Okay, so I'm going to go over the 4 projects real quick and then see if you have any questions, and then we'll move on. The 4 projects are on the overhead here. The first one basically is a motion detection with a photon Wi-Fi device. I got to show you on this LED. A motion detection Arduino. It's placed on a breadboard, which looks like this. And the wires go from the motion sensor to the breadboard. And then this is powered by, in this screenshot here, this one's powered by just a USB plugged into a wall. But the ones you'll be creating on in May are powered by a lithium battery right here. And so, and by the way, these lithium batteries only cost like $3. And they last about 3 months per charge. And so pretty powerful, right? So that's the first project. And motion, where can you think that motion detection is used right now already in your life when you go places? Where do you think motion detection is used already? You know it's used already. Do you think of any place? What?
Banks alarms.
Bank alarms, yeah, like in this room here even. When the room's alarmed, as soon as you walk in, that corner right over there, it's blinking red right now actually, it's a motion sensor. So it notices motion, and it triggers the alarm to start firing down, and it also triggers security that there's motion in the room if the alarm is set, okay? So banks, alarms, anything, think of other motion type of sensors that might be utilized where?
Lights that turn on, like on your garage.
Yeah, that's a great one. Yeah, so lights when your car comes into the garage, the lights turn on, or say you might have motion sensors in your house somewhere to where you walk in a room, the lights turn on. A lot of businesses do that to save electricity. So if nobody's moving in 20, 30 minutes, the lights turn off or something. Anybody think of anything else? Motion sensor? Yeah.
Automatic doors, like it's doors.
Very good, very great example. In fact, all your shopping centers, all your malls, mainly shopping centers have this, where you walk up to the door, Walmart has them, automatically opens up the door automatically opens up. That's been there for years, right? That's this right here. That's what you'll be learning to create. So with that motion sensor, you can trigger any type of mechanism to fire. basically. You can also, with this motion sensor, just trigger motion, and what it does in the lab we'll be doing is sends notifications to your cell phone of when motion's been detected, at what time, and what place. So you can literally set up your device anywhere that has Wi-Fi. It'll sense location, it already knows the time, and then it notifies you via a text message with notifications that we'll use that are free to use of when somebody walks across the path of that notification device. With that sensor, it lets you know. Yes?
Sorry. So if you were gonna set up something like that to turn on lights in your room, so there must be like another middle step there.
There is, yeah. You would have to have, this would have to fire a light switch or a light switch mechanism.
So a light switch mechanism would be needed then to.
In fact, you can already buy them actually. If you go to Ace Hardware or Walmart in the lighting section, you'll see in the light switch section switches now that instead of the on and off switch has a motion sensor. And so they already have those already in place.
So it wouldn't be anything that you could, like, if you left the lights on, turn off with your phone when you get to work or something like that?
No, this would not be that. This would actually be just for, mainly for practical purpose. The way we're doing the lab in May is for sensing motion and sending notification. That's the purpose of this one. Now you can take that and apply it to a whole bunch of different scenarios, but that's how we're tailoring it anyway, more practical use. The second one is, again, a practical. These are all practical examples. Is controlling a servo. This is a servo arm. The only thing servo means is it's a robotic arm, a servo arm. And so the servo arm is behind this is a shadow box frame and a piece of paper with little images like umbrella, coat, t-shirt, sunglasses, snow and hoodie to a shovel, okay? And so it goes out to AccuWeather every 15 minutes, and behind the scenes there's a little, right here behind this piece of paper, there's a motor, okay, a motor, and when it checks the weather, and let's say it says it's sunny outside, okay, well, might point to this one here, which would be t-shirt and sunglasses, because it's sunny outside. Well, let's say it's kind of cold out, might do this one right here, the hat and gloves type thing. So it'll check it every 15 minutes, move the actuator arm, depending on what the weather says. Now, the way this works is you can change the battery life or extend the battery life by changing the lookup to AccuWeather to longer time. So instead of 15 minutes, change it to check every hour or something. And that would change the battery life from lasting a month to maybe 2 months or 3 months without being recharged. That's kind of cool. And so that's the second project. Again, behind the scenes here is a motor. You see the arm already that's connected to the motor. And then this is just a piece of paper with artwork to tell people what to wear basically before they walk out the door. So that's the second project. The third project we'll be doing is this temporary, or this temperature reading project. This basically has a temperature reading sensor that reads humidity and temperature both. And then it notifies you via a notification every 30 minutes in this app. Every 30 minutes notifies you of the humidity and temperature in that region. You can also set it to where if the temperature goes below a certain threshold or above a certain threshold, it notifies you regardless of every 30 minutes or not, if that makes sense. This one, the wearables one, we're replacing with this. That's why I brought it tonight. We're replacing with the LED IoT. And let me show you that real quick, how that works on the app side of things. It's pretty cool. So you got what it looks like. And this is called Blinkly, or Blinks is the name of it. And it's a really simple GUI interface that you don't have to have any programming skills. You literally drag and drop text boxes, buttons. This one has a text box, and I think it's got 2 buttons, and that's it. The text box is to put in a message that you see on the screen that you can type in. And the two buttons, one button is to toggle between weather and text. Right now, you'll notice this text. I'm going to tap on the temp button here. And now notice it shows a Rockford weather. It just, right now, check AccuWeather. It's 50.56 degrees right now, according to AccuWeather. If I tap on the text button, it brings the text back. Then I'm going to type in that text box. Right now, you'll see the message. I just type that in. And then last thing I can do is there's an off button here. But before I do that, I'll go back to temp. And now I'll tap the off button, and you'll notice everything goes off. It looks like it, right? It looks like it's literally powered down, but it's not. It's in what's called low power mode. Low power mode is it still has electricity coming to the particle photon. The particle photon, by the way, is that very left image, the little bitty one next to the right of the sensor. But you'll notice in 60 seconds, it's going to light up again. I'm going to go ahead and, the app right now says turn on. It's in off mode. If it was to come on, you'll see it in a second. I'll let it go through the cycle 2 times. This first time, you'll notice the Blink app says it's in off mode. It'll check what the Blink app says. And since it's in off mode, you'll see it blink and come on a little bit and then shut down again. Now I have it set to where it will restart every 60 seconds. But you could set it to whatever. You could do it every 5 minutes or every 30 minutes or whatever the case may be. But this is for 60 seconds. It's starting up, blinking green, looking for Wi-Fi, connects the Wi-Fi with the blue, checks blinks, it says it's off. Now it's going to shut down here in a second. Blinking blue, and that's just basically the low power one. Now what I'm going to do is I'm going to go ahead and turn it back on. And now the next time it starts up here, 60 seconds, which cycles down, it will start back up here in a bit in 60 seconds, and then it will notice the app now says it's in on mode. And it should go to the last session, which I think was the weather one, I believe. Leave it on. But we'll wait and see. You'll see it. So you know that blue is kind of blinking really. It's kind of a cyan color, blinking really low, lighting. It's very low in battery usage. That was happening before, by the way. You just didn't see the blue, even though it wasn't blinking. The juice was still connected to the device. Electricity was. So here in a second, it's going to go to the 60-second threshold. You'll see the green blinking light, which the green blinking light means it's looking for Wi-Fi. It sees Wi-Fi, it turns to solid blue. Then it'll see what Blink's app says, that it's on. And then it should come up with whatever the last message was, whether weather or text. You'll see. But anyway, it's going to be 4 Saturdays. The date range, 18th, starting May 18th from 8 to noon, 4 Saturdays in a row. It's only 3 credit hours, and you will complete one of these projects each Saturday and be able to take them home. I'm going to give you like 4 other projects we will not do, but you can do on your own because you'll want to. I'm guaranteeing you will. And if you finish these 4, you want to do more. So yeah, that's a lot of fun. I've been doing it for about 5 years now. Developed quite a few of them on my own for businesses and personal use. And again, it's a lot of fun to do and to play with. Let's see, should be booting up here in a second. Turned on. says it is connected. I'll just charge this up and might get a little battery maybe.
That's pretty good.
Oh, probably I picked it up right. I'm connecting this to my phone too. There it is. Yeah, it's getting low on battery. Should be starting up here in a second. Anyway, I'll pass that around real quick. Okay. And the box I found for those, by the way, are a 4x6 photo box. Photos, 4x6 photos. Works great though. It's perfect because it all fits in there nice and snug and fits there perfectly. Questions while it's being passed around on the IoT course. 4 Saturdays. If you're not interested, let people know and share it if you wouldn't mind. That'd be great. Yeah.
There's credits involved in it, right?
3 credits.
Apply to any of the programs?
They would be considered an elective technically because it's not part of any degree really. If you need an elective or two, it'd be perfect, I think, to take. And again, if you're like me years ago when I got into IoT, I got into it because I was interested back then. But now it's even grown further. So, but yeah, it'd be considered an elective for sure. Good question. Any other questions? Yeah. 3 credits. Yeah, three credits, and 4 Saturdays from 8 to noon with check-in from 7:30 to 8. And the date range is May 18th through June 8th. May 18th through June 8th. The website is rbciot.app. I'll write up on the board if you want to look at later in more detail. And give more descriptions, and you can look at all the examples and stuff like that. But I'd love to have you. And then if nothing else, you can share on our Facebook and Twitter. If you could share the link, that would be awesome. Now I'm going to talk about a couple of the job postings that are on our website. Okay. All right, so if you go to myrec.org, first of all, the 2009 Summer 1, Summer 2 courses, the one I just mentioned, plus all the other courses that are available for Summer 1 and 2, all the CIS, PCT, and web. When you click on the link that says more info and registration, it'll bring you right to the page in online services where you could literally register right from there if you wanted to. And so if you just go to myrec.org, all the courses for our division anyway are right on that very first banner ad that says Summer 2019 courses. And I try to make it easy to where you guys can just click on the register, more information registration, and go right to, like the one I just talked about would be in the CIS information section. And it's the call letters on that one is CIS 290, special topics and computers and info systems. What that means is anything we want to teach is what we use for that class, basically. And so we have the same for our PCT section and our web section. Anytime you see a 290 in PCT, CIS, or web, it's a course, it's a special topic that's been requested by students or faculty want to teach forever. And we use that call letter to do that, basically. Because in the description on these courses that say special topics, it does not describe what that topic is. Okay, that's why I'm explaining it to you tonight. So it's CIS 290 is the one that is the Internet of Things course. And then you've got PCT has a couple special topics in 1 and 2, summer 1 and 2. It is both on the Python with networking, and it's PCT 290. And then Web 290, I take it back. On the second one, PCT 290 for summer 2, that one is a cyber security one. PCT 290 summer 2. And then the web, there's a Web 111 for summer 1, a Web 290 special topics for summer 1, and then a Web 101 for summer 2. So again, if you just remember my Receive website, you can click on that banner. Also, I wanted to talk about the jobs posted. There's 2 postings still on the jobs. One is for a programming analyst for Rock Valley. The second is for a seasonal IT department person for the Rock River Water Reclamation District. I'll read this one a little bit because it's a pretty good post. It's seasonal workers, what they're looking for in the informational technology department. Some of the duties they would perform would be preparing electronic equipment for salvage, machine inventory, asset existing technician with cabling, assist existing technician with cabling. So the Cat5 cabling like we did, you might do some of that. Minor hardware and software tasks, like installing software into computers. Maybe installing a NIC card or memory or something. Your hours would be 8 to 4:30 with a half-hour lunch. Qualified applicants must be at least 18 years of age, valid driver's license with suitable driving record, and be enrolled and planned to be enrolled in the fall semester of college. If offered the position, the applicant will need to pass a post-offer physical and drug test. Hourly rate is $10.25 per hour, and seasonal employees are limited to work 599 hours within a 12-month period. And then there's a link on where to apply. It's the RRWRD job application, which I believe is a PDF, which you would fill out and you would send to that employer. Okay? And you can send it via email, I believe, or just turn it in. So those are the 2 jobs. Questions on that? Cool. So if you're not interested in those 2 jobs, or you know somebody needs a job, you might forward that to them. And while I'm on our website, I did not mention, anytime I do a job posting, I always post on our Facebook and Twitter account. So if whether you're a Facebook person or a Twitter person, either one, I'll go to both. Here's our Facebook page. And it has events coming up, but then it'll also get into what we've already talked about, which is our code, learning robotics, coding, registering for summer 1, summer 2 courses. So that's the Facebook. The Twitter page looks like this. Talks about, like one just posted today, I retweeted, was if you need assistance in registering for summer courses, stop by tomorrow at the summer registration event, Friday tomorrow at 1 to 4 in the academic advising office on the 2nd floor of the Student Center. And I am going to be there, by the way, to help out any students that might have computer-related questions for computer courses. So if you're not following us on Facebook or Twitter, whichever platform you're on, I would do that. Make sense? That way when you get notifications, when we send notifications, you'll get those notifications immediately. Also on our site is an events calendar of all the events coming up in the semester through the end of the year. while I'm on here, I'll mention the hour of code or the learning coding with robots workshop, the one that we got the $30,000 grant for. It starts in April. There's going to be 2 workshops per month starting in April. And I need volunteers to help me. I could do it by myself, but I think I'd be totally beat and exhausted if I did. So if you could help, that would be awesome. You don't have to do it every Saturday, every time it's offered, but it's 2 a month starting in April. There's the dates, and they're right on our event page. You can click on the events to find it. If you go to the RVC events and go to any of the left side where it says Learn Coding with Robots workshops, you just click on the word events. It'll take you to all the events at the very top. And just scroll down the bottom of that page. You can see the registration. Click here for more information type thing. Yeah, there, that one. There you go. It's going to redirect you now. And then if you click on, there's a link on that where it says register now. If you click on that, it'll redirect you to this page that I have on the overhead. That's the Eventbrite page you're looking at. And so it basically gives you all the details of the workshop. And I need help with those dates. So if you need something to do on a Saturday, it's just for 2 hours. All you got to do is help people with computer questions. It's kids from K through 12 or K through 8. Their parents will be there. Grandparents will be there. You'll get to play with those robots as well. And normally students that help in this training, I try to give them a Nozzlebot to keep so you can take it home and play with it, which are a lot of fun. So look at those dates and let me know which one you'd like to help with. And I'll be very, very appreciative if you could do that. Questions on that? Cool. And again, it's a lot of fun if you've never done it. Yeah.
Where do these usually help?
It's here in the bottom floor of this building in the Mac lab. So you know where the big computer lab is downstairs. It's way back in the back there. We call it the Mac lab, but it's room 1112. Yeah, it's the only place down there that has all Macs back in there. So
where the hour of code was held before. Okay.
Yep, right there. So again, love your help. If you could give it to me, that would be great. And again, when you see posts about jobs or like what I just talked about, learning code with robots or our code, if you're on our social media, you can help by retweeting those and sharing them on your page. That would be a big help as well. And it just literally takes a click for you to do that. Sound good? Okay, so week 10, a number of things to go over. Your lab is a take-home, but we're going to help you with it first before I have you take it home and do it. But before we do the lab, I want to talk about this network calls lab in week 10. So I'm going to click on that to show you what it is. So the network calls lab is a lab where you will get a list of numbers from, excuse me, the local Rockford region or wherever you live. I suggest a list of like 20 companies, 20 businesses from ranging from hospitals to schools to insurance, places that sells insurance, any type of business, doesn't really matter, large or small. So let's say you get a list of 20 numbers. And the one students always call is the college here, all the local colleges, all the hospitals, any clinics you might go to, call them as well. So right there's a list of at least 10. So you get a list of numbers and you will call those folks and find out, and I'll give you a script to actually use. And the purpose of this is to find out what the Rockford region has as far as networking goes. And it also helps you to ask questions and start feeling more at ease on talking to people about technology stuff. And so you'll call and ask for a network administrator or assistant or IT administrator or assistant. If they say, I don't know what you're talking about, say, can I please talk to the computer person that's over your network? So you start out with more technical words like network administrator will be awesome, network assistant, IT manager, something like that. But there are going to be some companies that don't know what you're talking about that answer the phone, right? And you just have to say, whoever works on your computers would be great. So you say, okay, great. I'm going to transfer you to Joe or to Tammy. Joe or Tammy answers. Let's say they do answer. Many times they'll go right to voicemail. If they do answer, hello, my name is Chuck, a networking student from Rock Valley College. What's your name? Joe Simpson. Joe, I've been asked to call top 5 businesses to ask some makeup of their network. Right there, I put that in there for a reason. In sales, which I was in for a while, one of the first things you learn is you want to make people feel like you think that they are not only worth your time, but you think a lot about them as a person and you're interested in them as an individual and you try to, puff up their ego a little bit. And that's what you're doing. By saying immediately that you're calling them because they are a top 5 business, immediately their ears are going to perk up. We're going to perk up because they might have not had a compliment in years, maybe, or months, right? Because that's just how IT is. So you've already complimented them a little bit, so that helps. You got their attention. So you ask the makeup of their network. First, this is supposed to help me understand how networks are used by top businesses in a real-world setting. Could I ask you 7 questions about your network? Pause. The reason I put that in there, in sales again, number one thing you got to learn is the awkward pause, where there's no movement, no sound, and no questions. That's where the sale is made or failed, right? Because you ask a question, you lost it before they get a chance to answer you. So just pause and wait for them to respond. Once they respond, if they say, I'm real busy, I'm not going to be able to right now, you can come back with and say, I understand, I appreciate it. Would it be okay if I emailed you the questions? Would it be okay if I did that? More than likely, they will say yes, but they might actually say no. But either way, regardless of the outcome of that conversation, if they don't want to do it right now and they don't want you to email it, just say, thank you for your time and have a great day. Done, right? But if they say yes, quickly go through the list, all right? But even if they say yes and they feel like they're rushed for time, you feel like they're rushed for time, which a lot of times they will be, say, I can thank you for offering to let me ask you these, but if you're really rushed for time, I could email these to you as well if that would be helpful. And they would definitely appreciate that. And then, you can shoot them an email. And then you would email them these questions and they reply. So here's the questions. Does your network use Ethernet, token ring, or both? They might say, don't know. Great. Number 2, what is the transmission speed of your network? They might say gigabit, or they might say, don't know. Depends on who you're talking to. What type of backbone does your network rely on? They might say fiber and Ethernet, or all fiber, or all Ethernet, or don't know. Regardless of what the answer is, you don't need to keep asking. Just, thank you. Go on to the next one. What type of wiring does your network use? Is the same type of backbone as workstation. They might say, well, it's Ethernet from switch to computer, but from switch to server, it's fiber. They might say something like that. Or they might say, don't know. Do you use WAN technologies? What topologies are in each location arranged in? Again, we went over those topologies. Remember the star, the bus, the hybrid, the ring. They might say something like, one of those 4 might be hybrid or star. They might say, yeah, we have a WAN topology. Whatever they tell you, you're going to jot down. If money was no object, number 6, what type of upgrades would you make to your network? They might say something like, fiber on all computers, switches to servers, to maybe a new Nimble server or a new, mobile management tool or something to manage mobile phones or something like that. Whatever it is, the money's no object. Jot it down. If you only have money for enough money for one of those upgrades, what would it be? Again, what you're doing with some of these questions towards the end anyway, is you're actually, because in every IT department, in every field, but especially IT, there's always a want list that you want that you get down here, basically what you actually get. But you're always wanting this stuff here, right? So by you asking these questions, again, you're kind of feeding that the ego part of them that doesn't get fed too often and don't get listened to too often, maybe. And they're sharing basically their dream to you about whatever it is they want, right? Once you've completed it, thank them for their time. And you will upload each time. Let's say you get 20 calls and you get 2 replies. That's awesome. That's great. That's really good for sales. If you get 2 out of 20, that's like awesome. That's really good. So don't feel bummed out if you only get 2, right? Out of 20 of complete list. What I'd like you to do, and it's not on this sheet, is, and it's in a RTF Word document format, if you could put the name of the company at the very top somewhere, that'd be great when you save it. And then save it as that company name. So if it's ABC Company, save it as abccompany.doc or something like that. And then upload each one of those completed sheets to the week's lab, which is not due this week, by the way. If you go back to week 10, you'll notice it says it's due in week 12. So in week 10, if you forward fast to week 12, in fact, I moved it up to week 13 for you. It's in week 13. You have 3 weeks to finish it. So you go to week 13 and go to the network calls on week 13. Here's where you're going to upload it. And by the way, inside of week 13, I have the document again for you to click on to download. Okay. So you just download 1 document per call or per email response, whichever one you get.
We should fill out 5 of them, right?
Do what now?
We'd have to fill out 5 of them, right?
Well, you're going to call. I recommend calling at least 20 people. And if you get 2 completed, done, meaning they've completed 2, whether it be on the phone or an email, that's great. If you get 5, that's like awesome, like excellent, really good. It's really good. More than likely, you'll get a solid 1 or 2, okay, out of 20. Now, it's going to be different if you know some people maybe that work in IT. You might get a higher number, but more than likely, out of 20, if you get 2, that's a good number, to shoot for. Does that make sense? Yeah. And so the places I already mentioned, I would call like you're on campus. Call during the day, by the way, on every location pretty much. So here you would ask for the network administrator. Most of the network administrators have had the same assignment when they took this class years ago, because they all had this class sometime in the last 20 years. So they've done the same thing you're doing, basically. So usually they're pretty good here about giving you information, right? Coca-Cola is another cool place, the vending company or the distributor company. Pepsi-Cola is another one. These are just different places, right? Insurance companies. If you have your own insurance agent, right, which most of you do, ask them to give it to their IT person to answer the questions. They'd be probably more glad to do that. So you don't have to, in that case, you would have to talk to the IT person. You would give it to your insurance agent and say, hey, could you give this to your IT person to email me when they're done? Something like that, right? So you can be creative in the gathering of that information. Make sense? Okay, so that's 3 weeks you've got to do that. So that should be an easy one, hopefully. Other questions on that before we go on the call, network call? All right, cool. Next is in week 10, lab, there is a exercise that we'll go over here in the end. I'm going to go over my voice is almost gone again. My voice is totally gone Monday, but I can feel it going again. So we're going to quickly go over subnetting, but before we do that, and we'll go over this little exercise, and it's not going to be due till next week. When you come to class next Thursday, you will upload it into this section by next Thursday. But let me show you in week 10 some things that are important. We're going to be going over, there's 2 podcasts or 2 PDFs from chapter 9. And what I've done is in week 10, when it comes to the review questions and the quiz both, I put a link to the chapter 9 you want to use, which is version 5, chapter 9, which is the version you should be using. And you might have already had that, but there's also a version 6, chapter 9 in the folder up here at the top that says weekly slides. There is 2 chapter 9s. One is version 5, one is version 6. Version 6 we're going to use tonight because I like it because it goes over subnetting. Version 5 is the one that you'll be using for the quiz and the review questions. But I put a link in our course for the review questions and the quiz both for week 10. Okay. So use that link for week 10, review questions and quiz. All right. While my voice is still up and going here, I'm going to quickly move to the one I want to go over. Excuse me. Let's see. Nope. This is the one for your quiz. It's this one here I want to go over tonight. Yeah, version 6 is the one I want to go over tonight. Because it talks about subnetting. Subnetting basically is used in networking for separating your network into separate segments to where they don't cross one another. And there's more freer data flow by separating them. So an example is here on campus, we have a data segment, right, for computers. We have a voice segment for phones. So 2 segments for our network. We have other segments within data as well. So we have data segment for Wi-Fi, a data segment for wired. So all these fall on what's called segmenting, subnetting IP addresses. It's inside the TCP/IP suite, as mentioned on the overhead, and it is routable. Our IP addresses are within our control. We can do what we want to with it. So subnetting basically separates our network and subdivides it into logical, whether it be geographical locations, departmental boundaries, or technology types, like I mentioned, voice for phones and data for computers, to put simply. Subnet traffic is separated from other subnet traffic to where they don't crosstalk, they don't run into each other. Because years ago when I first started, we were on a flat network, meaning at noon, when we're getting a lot of calls on campus, calls would drop because the data would take over because it was on the same path, same flat network. So we switched it not too long after I got here to a two segment layer subnetting, which helped tremendously. So now when the calls come in on the campus, they're in a separate segment from the data, which is computers. And other reasons to separate the traffic is security, performance, and simple troubleshooting. For security is, if you're working on something in data related or even on phone related on the voice side, an important call with a student or important call with an accreditation society, doesn't look good for our campus to have a network to where you're talking to somebody from accreditation and the call just drops, right? That's not good. And they keep calling back and it drops again. That's not good. Doesn't look good for us, right? Security also in the fact that when data segments are overloaded, they're easily hacked. When anything's overloaded, like your own body, when your own body is overloaded with low immune system, you're more likely to get sick, right? Or, fall down or get hurt or whatever, right? Because you're a low immune system. You're just, barely being able to walk or something. Same thing with the network. When it's unhealthy and traffic is colliding, it's more security ramifications. Then performance, because it's different segments, things can flow better and flow faster. Data will flow better on a data network because it's on a separate segment from voice. And then troubleshooting, if we segment our network, we can troubleshoot easily because everything's in a different segment. Also, the next thing in subnetting is what's called classful addressing. You have three main types of classes in subnetting: class A, B, and C. So it uses basically the first three numbers of an IP address determines, and we'll go over this in the subnet exercise, but the first three numbers of an IP address determines the class. Okay, so this is the first three numbers of an IP address. So depending upon what that number is, depends upon if that class is an A class, B class, or a C class type of class. And we'll talk about that in a second, those type of things. We just know right now, the first octet or the first number set in an octet, which is going to be 4, you're going to have 2, 3, 4. This is the first octet, second octet, third octet, fourth octet. This octet here determines class. All right. So on this screenshot here, it goes over the subnetting breakdown as far as network information, host information. You'll notice on the top, class A, little bit of network information, more host information. B, more network information, not as much host information. C, a lot of network information, very little bit of host information. We'll talk about what all that entails here in a second when we go over your subnetting. But basically, just note this. Like here's an example of a class A, B, and C. Class A with an IP address of 114.56.204.33. The network information part of that class is 114, the first octet. The host information is the last 3 octets. B, the 147.1.2.3.8.8.1. The first 2 octets are network. The last 2 are host. On C, the first 3 octets are network, and the last is host. So when subnets are created, they identify, a subnet mask will identify how networks are subdivided, where the network information is located, according to the class, and it'll do what's called a subnet mask bit that corresponds, the number 1 corresponds to the IP version 4 address, 0 corresponds to IP version 4 address containing host information. 1 is network, 0 is host. The network class is associated with the default subnet. Remember when we did the local intranet lab, where I had you guys type in the 10 dot number, you hit tab, and then it filled in only 255.0.0.0. And I told you back then, the reason it only fills in the first octet is it's because it's a class A. It knows it's a class A. If it was a class B, it would automatically by default fill in 255.255.0.0. If it's a class C, it would automatically fill in 2 255s and then a .0 on the end, or 3 255s and a .0 on the end. The network class is associated with the default subnet. So here's an example. Class A, and it's giving you the binary subnet, the default binary subnet for class A, which basically that 111111111 is 255. Okay. You already know what 0 is, 0. Okay. But all ones in a byte, which is 8 bits, is 255. So you'll notice A is 255, one set of 255s and the rest zeros. B, 2 octets, 255, the rest zeros. C, the first 3 octets, 255, and the rest zeros. The number of bits used for network information on A is 8. Remember, because it only has 1 octet. There's 8 bits per byte. So each one of these is going to have 8 zeros or ones. So 8 bits per byte. And the first one, A, is the first octet is fulfilled, so that's 8. B uses 2 octets of 255, well, that's 16, 8 and 8. The third, C, uses 3 octets of 255, that's 24, 888, 88 and 8. Then the right gives you the decimal equation equivalent that we just went over. So in subnetting, they have what's called ANDing, which is basically combining bits of value of bit value of 1 plus another bit value of 1 results in 1. A bit value of 0 with a bit value other than any other bit is 0. So if it's 0 and something else, it's always 0. If it's 1 and 1, it's always 1. That makes sense? That's simple. You know, remember that in grade school. 0 and whatever is 0. Same thing in this binary. 1 plus another bit of 1 is 1. 0 plus any other bit, 1 or 0, is 0. Logic, 1 is true or on. 0 is false or off. Kind of like a light. It's just like a light switch, on or off. Binary. So the IP address bit, subnet bit, and resulting bit. So in this case here, we have just an example here of an IP address 199.348.9.1827, but this subnet, which is a class C, we know because it's filling 3 octets. And then on our handout tonight that we'll go over in a second, it goes over the different classes, how they're delineated. And then it gives lastly the network ID, which is 199.348.90. And that would basically be your server IP address for that location. So subnetting allows you to do what's called special addresses that can not be assigned to node network information. It uses a subnet mask. So basically you can have the same IP range, different subnets in that range, and it would separate the segments. So we could have in a network 2 IP addresses of the same IP address with a different subnet, and it would separate those 2 IP addresses from one another. The subnet is what actually separates it, which is that middle number. Just like when we did the LAN lab, you typed in the 10.0.1.1, hit tab, and the 255 was a subnet. Well, everybody in your group was in 255, so that's why you could talk to one another in that IP range that I had you put together. Now, the IP range does need to have a range to talk to one another as well. So like in the example of what we did in class, everything was at the same range of IP. It was a 10.0.1.1.2.3, I think, something like that. But everybody had a 255.0.0 subnet. So examples of a special address would be a network ID or a broadcast address. A couple things that are important to note. We'll look at more here in a second on your take home, but the local loopback, which is the local host, 127.0.0.1. It's a loopback function to test your NIC card, basically. And you just type in the IP config space or ping space localhost, which we've done in here, and it should give you 4 replies. That determines the health of your NIC. The next 3 are private IP addresses, okay, for a local network to use. Or you might have seen some of these in your home Wi-Fi router, possibly. Some of these ranges, maybe like the 192 range or the 172 range. Excuse me, that's a pretty popular range that Linksys and other Wi-Fi access points have by default. And unless you change them, it's probably the same, right? You might have changed the password, hopefully, but you kept the IP range as whatever was set by default. The link local is this 1692410 through this number is the link local. And then any address whose host is equal to 255 is a broadcast. Addresses where it's all zeros is a network ID. So when we're doing subnet techniques, basically you have to break down what class you're going to be in basically out of this slide and what subnet you're going to use. It's basically what you're going to be determining on a subnet. So this example here just gives class B and some subnet mask for class B. On the left is all the subnet mask. Well, not all of them, but some of them that could be for class B. And in the middle or the top, the middle and the right column gives the number of subnets available on that subnet mask and the number of hosts available on the subnet mask. Now, host means actual computers that can be connected to that network, okay? So you'll notice the higher number of hosts is the least amount of subnets available. Higher number of network subnets, least amount of hosts available per subnet. Here's class C. You'll notice lower number of hosts per segment and a very low range on subnetting on the network. We will not go over this calculation here because it's too confusing for you, but we will go over an example one on the handout here in a second. I don't want to go over this too much. Nope. Okay, so let's look at this. On the left side is a router, and the router is connected to, we'll just say, a 199.34.89 number. And you'll notice everything past the 89 is different, right? So we got a 34, we got a 32, we got a 64, 96, 128, 160, and a 192, right? Going in further out, first three octets you'll notice are all the same, right? Last octet, different, okay? All of these are now talking amongst several subnets. And what's going to be determining these subnets basically is that subnet IP address that you do not see on the screen. You're only seeing the IP address, not the subnet. So when you're subnetting in version 4, you basically have to deal with classes. You have to deal with subnet IP addresses. And so what I'm going to do now is exit that and go to your chapter 10 for me, if you would, and go into week 10 lab. And we're going to download that example or view it on your screen. In fact, I'm going to download it to my computer as a Word document. I think it should download it too. Don't do that. I'm gonna bring up the Windows one so I won't confuse you guys. Hey, bring up the Windows calculator. So bring up that document in front of you. I'm gonna bring up the Windows calculator with you. As soon as you bring up your subnet document, open up your calculator on your Windows computer, if you would. And I'm going to do a couple of the examples with you, but we're going to go over all 3 pages first and what it's all about, what you'll be doing, what you'll be taking home. And you're just doing a conversion, by the way, is all you're going to be doing. You're doing the conversion from IP to decimal IP. But you need to know how to do that first. It's not real difficult, but I will show you how to do it. Really, if you don't know already, to get a calculator run on Windows or anything, I have to use this shortcut on Windows for the overhead. Let's show my Mac or the Windows computer. Windows calculator. So see where you got the search program of files. If you just type in CALC and hit enter, it'll pop up Windows or calculator. We want to view the programmer calculator, view programmer, and then it should be on decimal right now, but I want you just to show you, if you click on the bin radio button on the left, it'll change it to only be available for 0s and 1s. DEC is 0 through 9, but bin binary is only 0s and 1s, okay? So on the handout, you'll notice the very first page says, use the first number of IP address to identify the class and associated subnet. Calculate the network ID using the numeric values of the IP address that correspond to 255 in the subnet, and then fill in remaining parts with zeros. Calculate the host ID by using the numeric values of the IP that correspond to the subnet. Before we do that, go to page 2. Page 2 will help us with what classes are what really easily, right? So you'll notice on page 2 at the very top, it says class A, B, and C on the left. Then it says value for W, network portion, host ID portion, available networks, and host per networks. All right. So let's look at A, value for W. W means, well, let me show you on the overhead on the board. We already have 1, 2, 3, 4. We also have W, X, Y, and Z. So first octet W, second octet X, third octet Y, fourth octet Z. Make sense? So first octet, which is W, if it falls in the 1 to 126 number, guess what? It's a class what? A. If it's a 128 through 191, it's a class B. Where's 127 at? Anybody know? We'll look at that in a second. 192 through 223 is a class C. Thank you. Now you'll notice the network ID, it says here underneath, follow the guidelines of assigning network ID. The network address must be unique to the IP internetwork. If you plan on having a direct routed connection to the public internet, the network ID must be unique to the internet. Okay, now when it talks about network ID, that's the first octet, that's W. Okay, so a 10 dot number, is that going to be a class that we can connect to the internet? The network ID we can connect to the internet, a 10 dot number. Can we connect that to the internet? if it's going to be on a public internet connection? Yes or no? A 10 dot number. Well, read the first bullet. If you plan on having a direct routed connection to the public internet, the network ID portion must be unique to the internet. If you do not plan on connecting to public internet, the local ID, network ID must be unique to your private internet. Okay? So, Class A's generally, for public internet usage anyway, are not going to be, that's why when your routers at home are set to the Class B range, you'll notice, which is 128 through 191. So, bullet point number 2. The network ID cannot begin with a 127. That's reserved for a local loopback. Remember, 127.0.0.1. Third bullet point. All bits within the network ID cannot be set to 1. All ones in the network ID are reserved for the IP address. And for the first bullet, what that's referring to, by the way, is websites. Okay? If you have a web server, that web server IP address needs to be what? The same as other IP addresses or different than every other IP address in the world? What do you think? What's it say on the first bullet point there? If you're connected to a computer, is connected to the public internet like a web server is, like google.com, GoDaddy, msn.com, each one of those web servers, do they have to have a unique IP address, or can it be the same as another one in the world? How many things unique? It has to be unique. Yeah, that's what that's referring to. The fourth bullet. All bits within the network cannot be set to 0. Zeros are in the network ID are used to denote a specific host on the local network and will not be routed. Here's the following non-routable IP addresses as is referred to in the white paper RFC 1918. These blocks of addresses can be used for private networks. So when you go home tonight, when you go to work tomorrow, check your IP addresses for your workplace or your home place. It will fall in that range. One of those 3. The 10.0.0 number, 172 number, or the 192 number. It'll always fall in that range for work or home. Make sense? Those are routable, meaning you can do whatever you want to in those ranges in a local internet, like we did for the lab in here. Which class did we use for the lab in here when we set up the local LAN? And remember? I talked about it earlier a couple times.
2.50.0.0.
It's a smaller number. And everybody ended with a 1, 2, and 3, remember? What was the first opt in an IP address? I remember? It's 10, yeah. So what class is that? A, it's A. So we all did A in here, and that is a routable, or a non-routable address that we can use as a private network, which we did. On this computer here in front of me, let me see here. I'll show you on the overhead. In fact, you can do it with me. If you do click on the start button and type in the letter CMD in the search box and hit enter, I want you to type in the word ipconfig, all one word, ipconfig, and then hit enter. The very top IP address is going to be your IP address where it says IP version 4 address. There's mine right there. It will be underneath the heading of Ethernet adapter real world NIC, I'm guessing. You're going to click on your start button where it says search program text box there. Type in the letter C, Charlie Mary Detroit, CMD, hit enter. And then type in the letters IP and then CONFIG, hit enter. The very top underneath Ethernet adapter real world NIC, you'll have connection specific DNS suffix link local. Then the next will be IP version 4 address. That's your IP address. Mine's a 172.200.25. What IP class route do we have in this classroom? I'm guessing everybody's a 172, right? So what class are we in here?
Medium.
B, right? And we're in that second tier, excuse me, B in this classroom. All right, so with that knowledge, now we'll go back to page number 1. Back to page number 1. Enable editing. I'm going to do the first couple with you. So we already know the first one's done for us, by the way, the 192.102.919.723. What class? It's B. We know if it's a B, going to page 2, if it's a B, the network ID portion is W and X, meaning the first 2 octets. If it's an A, it's the first octet, subnet. If it's a C, it's the first 3 octets, meaning depending on W, X, Y, and Z, depends upon how many 255s are in that subnet, all right, for network ID. So on the first example, it's B, 2 octets, W and X, so 255.255.0.0. The network ID portion is the first 2, which is 192.102.0.0. The host ID is the last 2. So let's go to the second one. Somebody tell me what class 131 is in. You can look on page 2 if you need to.
B.
B, what's a subnet? It's W and X, remember. So what's a subnet going to be? It's going to be the same. Yep. So somebody just said it. What was it? Yeah, 255.255.0.0. So go ahead and type that in. What's the network ID portion? It's going to be the same octets used, by the way, for the network ID portion. So what's the network ID IP address? Or the 2, is it the first 2 or the last 2? First 2. So let's go and type in 131.107.0.0. And what's the host ID? 2.1. Got that? Now, I will tell you there's a tricky one on here. I'm not going to tell you which one, but you'll need page 2 to help you with that. So I did that one with you. Let's go to page 3, which is the last one. Next to the last one. Page 3, we'll do that together. This one, we're going to convert an IP address following table to binary. The first one's done for us. I'll do the second one with you using a calculator. We'll convert the first decimal to binary, second, third, fourth, fifth, or fourth decimal to binary. Then number 5, we'll add leading zeros to the binary, resulting in a complete octet, and separate the 4th binary octets with decimal points. So you'll notice the binary portion column, we're not concerned about 8 places. We're only concerned about strict conversion, okay? When we go to the binary IP portion column, it has to be 8 solid bytes. But you'll notice, or bits, you'll notice in the binary IP address column of the example, zeros are added to the front. Leading zeros are added to the front to fill up to complete 8 bits per byte. Make sense? So let's do this. Let's do the second one. All right. So 215.34.2119. So with your scientific calculator, I'm going to do the first one. I'm going to go around and ask people to help with the rest of them. So 215. Make sure your calculator is set to DC. Make sure, first of all, it's programmer. DEC, and I'm going to put in 215. Then I'm going to click on bin. It's 11010111. So I'm going to go and type that in. I will move the screen around a little bit here so I can see it a little bit better. Come on. There we go. All right. You might have to do the same on yours. Excuse me. So 11010111, comma. Well, that one you'll notice, does it have 8 bits? It does, so we don't need to worry about it for the later. Somebody tell me the second binary. It's 34. So in the scientific calculator, click on DEC. Type in 34, and then click the bin. Somebody tell me what the bin is. Binary?
100010.
1 0 0 1 0.
Yeah, 1,010.
1010. Got it. 1 0 0 1 0. Is that correct?
1 0.
1 0 1 0.
Yeah.
Got it. Right. Third one, which is 211. Somebody else tell me what 211 is converted to decimal. Decimal to binary. Somebody, it's not white yet. Yeah.
Oh, 1 1 0 1 0 0 1 1.
1 1 0 1 0 0 1 1.
Yep.
Correct. And then somebody else tell me 9 converted to binary. Not all at once, please. It's too much. It's too much.
1001.
Thank you. 1001. Okay, so what we do now is easy. Copy that whole section with your mouse and copy. Do a Control-C once you copy with your mouse, and then paste it over on the right column. The first octet's okay, but we got to replace the commas with periods first. Let's do that. Get that done. Replace commas with periods. Then each octet that does not already have 8 bits, we have to put leading zeros in there to complete. So the second octet, how many zeros do we have to add? Anybody? 2? I only have 4. I have 1 0 1 0 in the second octet, right? So how many zeros do we have to add?
Well, I thought it was 1 0 0 1 1 0 0. I thought it was 1,000 and then
1010, right? That's what it was.
it was 1,000 0 1 0.
1 0 0 1 0. Okay. So it's 10,010, right?
Yes.
Okay, gotcha. So how many zeros do we have to add to the second octet?
Actually, it's 100,000.
100,010. Thank you. Very good. So how many zeros? 3. All right. Fourth octet, how many zeros? Are we good on the fourth octet? 1 1 0 1 0 0 1 1. That's 8, right? So third octet, I'm in. Fourth octet, how many zeros? At 1 0 0 1, right? 4. So we'll put 4 leading zeros in that. Done. That's it for that one. Okay. Let's go to the last page. This one we're going to do the opposite. We're going to take a binary and convert it to binary convert it to a decimal. First one's done for us. I'm going to do the second one with you. So I'm going to have you guys help me through my voice about ready to go. So somebody give me the first octet in that second row, what the decimal is. Once you get it.
169.
169, okay. 169, comma. Somebody tell me the second one. Once you get it. What is it?
85.
85. Third one. Somebody else? What is it? 70?
170.
170, okay. And then the fourth one, somebody else?
$216.
215?
$216.
216, all right. So we've separated those by commas. All we have to do is copy that, paste it into the third column, the decimal IP, replace the commas with decimals, and that completes the second row and the final exercise part 2. So I've done with you part 1, which is subnet exercise, find out the class, the subnet, and then the network ID, host ID. Remember, there's a tricky one on that one. Page 3, I did the second one with you as well, which is the binary to, or decimal to binary. And then lastly, binary to decimal. You'll complete all of those, save it, and then upload it into week 10 when you're finished, all right? So I think I said have you turn it in, but I'm gonna have you just upload it to save paper, if that's okay. You don't have to print it out. You shouldn't have to print it out, save some paper. So I think I maybe make sure I give you rights in here to upload. Text entry file or a file upload. Yes. So you do have rights to upload in here. All right. So once you're finished, you will upload it. It says hand in next week. I want you just to upload it into this location to save paper. Sound good? Questions on the take home. All right. And then you have your exercise we already went over, which is your review questions, a quiz. A link for the PDF is in those two. And I will show you what that looks like. In the review questions, I have a link to chapter 9 that you need to be with version 5. And then in the quiz, same thing, PDF to chapter 9. Questions? All right. Well, we are done. As soon as you get that saved or whatever you want to do, or do it all over again when you get home, that's great. If you have any questions about IoT class or any summer class or volunteering for the robotics or our code, see me before you leave. Otherwise, we are done for tonight. Great job. Enjoy the weather, by the way, for at least a little bit. It's supposed to get cold again this weekend.
I have a question.
Yep.
How do I download this into a Word document?
How you download what?
This into a Word document?
Okay, I can help you with that.
Because it just takes me to a completely different.
Yeah,
thing
so
that I
click
can't
on
edit.
the, where it says Subnet exercise link, that one, click that, yep.
Okay.
And then over here, the little arrow,
Oh,
that download, should download it for you as a Word document.
oh,
Cool?
thank you.
Yeah, it's a little tricky. Those cloud drives are a little tricky like that. Cool.
Is there a way for me to do this stuff once I come?
Are you in Java?
I only have the
I swear I saw you.
Oh, you want to say what you want?
I didn't want to like go like, hey, and then go like, oh, wait,
Is that possible?
Possible to complete it?
To see what I work on.
Oh, yeah, that- yeah. So just, are you, you're on the computer right now, this is work on it, right?
Right.
Yeah, so just go ahead and do a file save,
yeah, but the next week's.
or do a save as.
I've already been, I've literally been like doing like
click on
super
desktop.
advanced, because like I
And then
I
just
have no
click
like
save.
basis of how to do it, the partial.
Okay, now, go to your email in Eagle, it's fine, you can send it to yourself there.
Like,
Oh.
it's kind of, so.
So go to Eagle, go to the interaction.
Once I get trained up on everything, then I'll be able to.
I'm saying just go to your email, go up here to
like
Eagle,
2.5 hours long, so I'll just be like sitting here watching it.
right, go to your email. Yep, and send yourself an email, go here to the right,
Yep.
and put in select course, which is 110, to, put the, well, you can put it over here to see the name for the students, select yourself. And then there's something, and then, click on the paperclip, and go to the left to the desktop, double click on desktop. Click on desktop, and you should see that work document in there. I think it's 11.7 or something.
Oh.
Double click on that, and then send it. You work. Looks like a text right in there. Send it. Oh, okay. And make sure that's your XP. All right, cool. You just send it to yourself. Yep, you are welcome.
Hey, so I've been trying to, as I've let all my professors know this, I've gotten just probably a full-time job.
Yeah.
So I was telling all my other professors that it shouldn't be a problem, but all of a sudden I'm like drowning in homework and everything. I have like no time.
Right.
So I'm managing it.
Right.
I wasn't necessarily expecting to get a full-time job anytime soon.
Right. You're doing the best you can with it.
Yeah, so I'm doing the best I can. It's been a
Hey,
lot
so
of it's been a lot of just like nonstop work, making sure I'm caught up and
No
everything.
sleep, got it.
Yeah. So yeah. It helps me not procrastinate.
Yeah, exactly.
But,
Right. About time to, right?
Yeah. Yeah, so it should work out. Everything should work
Okay.
out. I've got everything figured out for next semester. I'm going to be taking night classes and working in the mornings.
Nice.
So all that's figured out. It just wasn't necessarily
this
the plan
semester,
for this
yeah.
semester.
That's a wrench in it a little bit.
Yeah, so I was, again, it shouldn't be a problem. I just know, at least right now, I'm like super busy.
Right.
I'm trying to, and this is just more work I'm putting on myself, but I'm trying to write individual, man, this is terrible saying this. I'm trying to write individual encouragement cards to all my coworkers from the job I'm quitting.
Oh, nice.
Because that's what my church did, and I did it for my students and everything.
Right. That's good. Yeah.
But
a lot of work, though.
they were an encouragement to me. So I was like, I want to encourage you guys, because I was only there for like 5 months.
Nice.
So I've written, I want to say 12 right now. I have 20. There's 28 employees there.
Oh, wow.
So it's going to be, and I quit on Saturday. So it's going to be a lot of work.
Yeah.
And I still have fun.
Yeah. Well, you'll get it done. You'll get it done. You'll feel better after you do it.
Yeah,
It'll be a lot of work, but you'll feel good.
It'll definitely be worth it.
Yeah, for sure. Definitely.
But yeah, I thought I'd at least let you know.
Oh, thank you. Appreciate it.
Yeah.
Well, hang in there and just keep trudging along, but you'll be fine. So
Yeah.
Make it.
Thank you. I appreciate it.
Yeah.
You have a great night.
Hey, you too. Yeah.
With the Internet of Things class.
Sure.
I'm almost done with my degree for
Okay.
CIS.
Gotcha.
I was wondering if that class would count as an elective towards that.
Oh, definitely. Yeah, it definitely will count as elective.
Okay.
For sure.
Because I did already advanced C++ and
Right.
iOS.
Right.
So.
Yes, it will definitely count as an elective.
Okay. And then the last question, with the mobile development certificate,
Mm-hmm.
you just need logic and design, iOS and Android, right?
That's it. That's three. You got it. Mm-hmm.
Okay. So I'm just one off.
Cool. And you're going to complete that, right? You're
I'm
almost over.
going to go for it because it
Cool.
just looks good on a resume.
Oh, yeah, we'll look good on resume.
Yeah.
All right, buddy. Have a good weekend.
Okay, last quick question. I know this is gonna be dumb, but
No, that's no
But
dumb
it
question.
is.
No, not.
I have a 13-year-old who I think would be super
Oh, yeah.
interested.
What grade
He's
is that
come
now?
along
What grade
with-
is 13?
He'll be going to be a freshman next fall.
Okay, I've had freshmen actually in my high school. I taught high school for years. I've had freshman level. I've actually had low as 7th, 8th grade level in my college courses. So
That's what I was wondering. Do I register?
He can
him,
definitely-
or does
yes.
he come with me?
you would register him, you'd bring him to campus and
I'm
register
not
him,
sure.
or online or whatever, however they do it now. I know that the parent has to be the one in that process. I do know that.
Okay.
Now, what schools do you go to?
We're around the country. He goes to Eswood
Okay.
right now. He'll be going to Rochelle High School.
Okay. Well, actually a great time right now. Tomorrow, the admission office is actually having a thing from 1 to 4. I don't know if you can make it. Well,
can't do anything.
I would call.
That's the other thing too. Is
I would say I would call admissions when you can,
Okay.
like sometime tomorrow if you can. Won't take 5 minutes to ask them
Okay.
what the process is to enroll your 13-year-old
Okay.
on campus, because I know it can be done, because I've had a number of students. Yeah.
In the summer.
Because the 2 girls that took my iOS class were like 11 and 12,
Okay.
just so you know. The parents enrolled them. Both of them had. One of the parents worked here, another one worked elsewhere. But I know that the mom told me it was super easy. They just had to register them, sign a piece of paper, done, and they were registered.
Okay.
There's no textbooks required. So that's a benefit. I'll be developing all the curriculum. It's already been done. And so the only thing they'll need is, show up on Saturday, ready to work, and
And that's the
learn.
other thing. Can he come alone? Because
He
I
can
would
come
have
along.
to
All the
switch
2 girls
my-
came by themselves. The
Oh,
mom dropped them off
Okay.
in the morning and then picked them up at noon.
Okay. 'cause
It
I would
was
have to
Saturday
switch
class.
My schedule.
No,
And
it's a Saturday class, and you'll
Fine.
drop them off like you normally would
Okay.
anywhere, and then just pick them up when the class is over.
Okay.
Yeah, no, that's
And
fine.
then the last thing would be what the cost for that. Is that a regular 3-credit cost?
Regular 3-credit cost,
Okay.
whatever the credit hour it is now, times 3
Okay.
is the cost. That's
Okay.
it.
Okay.
Cool.
Perfect.
Well, I look forward to it. That's great. What's your boy's name?
Sam, I'm not sure if we'll be be able to swing it
No, you know.
crosswise. I'm gonna ask him about it and.
Yep. Show him the
I'll
website, show him
yeah.
what we're doing.
Yeah, I'll show him
And if he
that,
has a
and then-
question, he can ask you or he can ask me via email if he wants to do it.
Okay.
I'll be
And
more
I'm
glad to
gonna
answer it.
count on, well, if it will count towards my thing too.
Yeah, it's
it'll be
like I was telling
able-
the student that just left, it will count as a general elective for sure for any degree you're taking.
Yeah,
count
so
towards
if it
that.
works for me, I could do that one.
Oh, yeah.
For free, and then I could pay for his.
Right, makes
So
sense.
that
There you
would
go.
be really
That'd be
awesome.
ideal, right?
Yeah.
Cool. All right, we'll see you. Have a good weekend.